Good day, class. This is your Kenny again with another topic regarding thermodynamics. In this one, we're going to describe the heat flow and calorimetry, which is STM006 module number 9. Before we begin, let us proceed to our objective. So, by the end of this lesson, you can say that yes, I can calculate the heat flow in a system. So, let's dive into calorimetry. Now, we have already discussed what heat is. When we say heat, it is the transfer of energy between objects due to a temperature difference. So, it means na kapag merong pagkakaiba sa temperature, the heat will be transferred from the area or from the object with a higher temperature towards the object with the lower temperature. Let's describe the images. So in the first image, the system will release heat towards the surrounding. So therefore, the reaction is exothermic. Exo meaning exit. It will exit the system. Another way to say this is when the amount of heat released is much greater than the amount of heat the system is absorbing, then the reaction is exothermic. On the second one, if the surrounding releases heat wherein the system will absorb it, then that means the reaction is endothermic. Endo meaning enter. The heat will enter the system. Another way to say this is that if the system is absorbing heat at much higher amounts than the heat it releases, then that means the reaction is endothermic. So let's go to the definition of calorimetry. So when we speak of calorimetry, it is the measurement of the flow of heat through a system and its surroundings. And the device that is used to measure the amount of heat or the amount of the flow of heat is called a calorimeter. Calorie meaning heat, meter meaning to measure. So the calorimeter will measure heat. So this is a typical setup of a styrofoam calorimeter. Now, we have the thermometer, which will measure the temperature. We have a double styrofoam cup, wherein it will try to prevent heat loss between the system and the surrounding. And we also have the stirrer. So the stirrer is ring-shaped. That is because that is for us to be able to stir the contents of the styrofoam cup at a much more efficient rate. Para hindi lang dito sa part na to, ang ma-stir kapag inikot mo yung stirrer. Since pabilog siya, hanggang dito sa kabilang banda or sa kabilang side ng thermometer ay ma-stir din. So, we have the formula for the heat. Heat is equal to mass times the specific heat times the change in temperature. So Q stands for the heat energy, which is either absorbed or released. Nakadepende yan sa sentence. Kapag ang sinabi ay released, then that means our Q will become negative. Kapag sinabing absorbed, then our Q will become positive. M is for mass. C is for the specific heat. Specific heat is read as joules per gram degree Celsius. So kapag sinabi natin na specific heat kasi, it is the amount of heat na kinakailangan to increase the temperature of 1 gram ng isang substance to 1 degree Celsius. So, gaano ba karami yung amount ng energy na kinakailangan para tumaas yung isang gramo ng isang bagay up to 1 degree Celsius. So, yun yung ibig sabihin ng specific heat. And then, delta T, delta means change, and T stands for temperature. So we have to identify the change in temperature. So much calorimetry is carried out using this type of calorimeter. So if we assume that no heat is lost to the surroundings, then the energy absorbed inside the calorimeter must be equal to the energy released inside the calorimeter. Ibig sabihin, yung amount ng energy na inabsorb will be equal to the amount of the energy na ni-release. So to cut it short, the Q absorbed or the amount of heat absorbed will be equal to the negative of the amount of heat which was released. So hindi pwedeng mas mataas yung isa or mas mababa yung isa given that there is no heat loss to the surroundings. Now these are the values of various specific heat of substances. As you can see here, mapapansin nyo dito sa some of the list of substances na sa mga metals, mas mababa ang kanilang amount of specific heat. Ibig sabihin na mas mababa ang value ng specific heat, mas mababa yung kinakailangang amount ng heat in order to increase the temperature of the item ng 1 degree Celsius per gram. So this is our formula. Q is equal to M times C times the change in temperature. Now, there will be cases na kung saan hindi lang amount of heat ang hinahanap. There will be instances na kung saan mawawala yung mass, yung specific heat, or the change in temperature. So, alternatively, we can derive the formula by dividing the adjacent values of the missing value to both sides of the equation. So, for example, yung C ang nawawala. So, sino ba yung mga adjacent values ni C? It is M tapos delta T. So, kung sino yung mga adjacent values yung nawawala, they will become our denominators to both sides of the equation. So, i-divide natin yung kasama nung nawawala to both sides of the equation. So, originally, this is our formula. Now, since nawawala ang C, yung mga kasama ni C, which is M tapos si delta T, magiging denominator on both sides. So, M delta T, M delta T. And then cancel the similar units. So, makakancel si mass, makakancel si change in temperature. So, therefore, C now will be equal to Q over M delta T. Ganun din sa mass, kapag nawawala ang mass. This is our original formula. Dito sa ating formula, si mass ang kasama niya ay si C at delta T. So we're going to make use of these two units na pang-divide sa both sides of the equation. Divide both sides by C delta T. Ayan. Tapos cancel C delta T on this side. So M now will become Q over C delta T. What if the change in temperature is missing? So, same formula. We're going to derive that. Nawawala ang value ni delta T, kaya kung sino yung mga kasama niya, which is MC, ay magiging denominator on both sides of the equation. So, MC, MC. Next, cancel the similar units. So, cancel mass, cancel specific heat. So, the change in temperature will now be equal to Q over MC. In order for us to practice, let us answer 3 questions. So number 1, how much heat is absorbed by liquid water that weighs 550 grams as it is heated from 25 degrees Celsius to 95 degrees Celsius? So first, let us determine the given. So Q is missing kasi ang tanong ay how much heat. Next, absorb, sabi niya. So that means the value of Q, kapag na-solve na natin, will become positive. Mass is equal to 550 grams. Our C, since we are referring to liquid water, hanapin natin siya sa list. This is liquid water, kaya 4.18 joules per gram degree Celsius. So, this is our value for C. Next, delta T is the change in temperature. Now, in order for us to compute the change in temperature, the formula is delta T is equal to T2, or the final temperature, minus T1, or the initial temperature. So, dito sa question, from 25 degrees Celsius to 95. So, ang final natin dito ay yung 95 degrees Celsius. Kasi galing sa 25 degrees Celsius, napunta sa 95. So, final ang 95 degrees Celsius at initial ang 25 degrees Celsius. So, 95 minus 25 is 70 degree Celsius. Before you proceed, make sure na kung ano yung unit ng ating specific heat, yun din ang unit ng lahat ng given. If not, then you have to convert. So dito, joules per gram degree Celsius. So the unit of heat should be in joules. Missing siya, pero ang lalabas dito ay joules. Next, unit for mass is grams. Unit natin ay grams. The unit for temperature is degree Celsius, degree Celsius. So we can proceed. So, since Q ang nawawala, the typical formula, M, C, delta T. Now, we are going to substitute the values. M is 550 grams. C is 4.18 joules per gram degree Celsius. And then the change in temperature is 70 degrees Celsius. Now, cancel similar units. So, you will be left with joules. So, our amount of heat is 160,930 joules. Is it positive or negative? Based on the question, how much heat is absorbed? So since it is an endothermic reaction, kaya Q will be positive. So this is positive 160,930 joules. Next, number 2. How many grams of lead can be heated from 20 degrees Celsius to 75 degrees Celsius using 12,500 joules of heat? So let us identify the given 12,500 joules for heat. Our specific heat, since lead, it is 0.13. So 0.13 joules per gram degree Celsius. The mass is missing. The change in temperature is 75 degrees Celsius minus 20 degrees Celsius. So it is 55 degrees Celsius. So M is missing. So we have to derive the formula, wherein after deriving the formula, we will get M is equal to Q over C delta T. Now substitute the values. M now will be equal to 12,500 joules divided by the product of C, which is 0.13 joules per gram degree Celsius times 55 degrees Celsius. Cancel the similar units. You will be left with grams. And then finally, after computing, we will get 1,748.25 grams of lead. Third one, what is the final temperature after 84,000 joules is absorbed by 10 kilograms of basalt at 25 degrees Celsius? So sabi niya, yung basalt daw, it is existing at 25 degrees Celsius at siya ay 10 kilograms. Paano kapag nag-introduce ka ng heat at 84,000 joules? Ano yung kalalabasan na temperature ng 10 kilograms ng basalt? Okay? So identify the given. Our Q is 84,000 joules. Sabi niya absorbed, kaya positive. Next, the mass is 10 kilograms. Our C, or the specific heat for basalt, it is 0.84. So 0.84 joules per gram degree Celsius, and that the change in temperature is missing. So if the change in temperature is missing, our standard formula can be derived, and then ang kalalabasan ay ito. The change in temperature is equal to Q over MC. Now, substitute the values. Our heat is 84,000 joules. Our mass, ito ang unit natin ay kilograms. Pero dito sa ating specific heat ay gram. So that means kailangan mag-adjust ng ating mass in order to have the same unit ng ating specific heat. So since dito ay grams, so ito ang mag-a-adjust. Si kilogram magiging grams. So times 1,000. So 10 kilogram will become 10,000 grams. And then the specific heat, which is 0.84 joules per gram degree Celsius. So cancel similar units, you will be left with degrees Celsius. So the change in temperature is 10 degrees Celsius. Pero hindi pa yan yung sagot. Kasi change in temperature pa lang yan. Ang hinahanap ay kung ano yung final temperature, given that our initial temperature is 25 degrees Celsius. So in order for us to determine the final temperature, we must derive the formula for the change in temperature. Kasi 'di ba, ang change in temperature is equal to T2 minus T1, or the final temperature minus the initial temperature. So we have to derive this again. T2 will become the initial temperature plus the change in temperature. So T2 now will become 25 degrees Celsius plus 10 degrees Celsius. 25 is the initial, nandito. Yung 10 degrees Celsius, ito yung change in temperature. So, the final temperature, or T2, is equal to 35 degrees Celsius. So that concludes our topic for calorimetry. You can now proceed in answering your module.